Everyone, today we have discussed about the basic of spectroscopy and posted a video on YouTube. And I also mentioned that recently the trending of the questions which was asking by the RPSC is going to change. They are asking multiple questions in a single question, so that more and more time will be taken from the students, as well as students get confused and they can get easily silly mistakes. Okay, so thereby what we are doing, we are framing such kind of test series wherein the multiple questions or multiple conceptual based questions was asked in single question, right? So similarly, just like similar to the spectroscopy, the inorganic chemistry, organic chemistry and physical chemistry test series has been prepared for your examination. So let's see these questions, and after that we will provide you that test series on, and also we will provide the telegram link so that you can access the test series and you can boost your examination preparation, right? So let's try to solve these questions. First of all, see, in the single questions they are asking IR, UV, NMR and mass spectra questions, right? So the four concept in a single questions also. So let's try to solve. Toluene and benzyl alcohol can be distinguished by the IR spectra. Thus, yes, it is completely true. That is the structure of toluene, and that is the structure of benzyl alcohol. What you see that in the benzyl alcohol there is a prominent peak of OH that is around 32003600, and you will see there is a broad and prominent peak. Okay, in case of benzyl alcohol due to the hydrogen bonding. Also, that kind of hydrogen bonding or broadness will be absent in case of toluene. Yeah, there will be other peak, and also there is a CO peak, that is a again characteristic peak of in case of benzyl alcohol around 10 and 16 centimeter inverse, right? So that is a basic characteristic difference, so that statement is a true, that we can easily distinguish these two compound with the help of IR spectra. Number two, so that is true. Number two, that 1,3-butadiene may be distinguished from 1,4-pentadiene by their UV visible spectra. That again, let's see, 1,4-butadiene, that is the structure of 1,4-butadiene, and that is the structure of 1,4-pentadiene. You can see that UV spectroscopy basically used to find out the conjugation, right? So here you can see that there is a clear conjugation, while in case of the compound B or 1,4-pentadiene, there is a disruption of conjugation by the CH3 carbon. Okay, so in case of first one, lambda max will be maximum. In case of second one, lambda max will be lower. So you can also take a reference of values, that there is a 217 nanometer and there is a less than 200 nanometers. Okay, so again that this particular statement is a true. Now the third one statement, that cyclopropane and propene cannot be distinguished by the NMR. Let's see, that is the structure of cyclopropene, this one, and the structure of propene. So we will make a structure of propene, this one, this, and that is the structure of propene. And in case of cyclopropene, the all 6 protons are in a single environment. They will give a single peak in 1H NMR. While in case of propene, this will give a single peak 1, that will give another one 2, 3, 4. Now you will see the both proton are connected to the carbon atom and still they are giving different peak. Yeah, just because their trans environment is a different, thereby they will provide the different del values. So which one will provide the more del values? Those have more del shielded, or those have more electron deficient. So which one is a more electron deficient? The H3 is a more electron deficient as compared to the H4, because in case of H4 there is a trans methyl group which will like supply uh, the electronic environment with the help of their plus I effect, right? So there will be less value of delta in case of 4. So del value order H3 is greater than H4, right? And the number of signal is a 4 signal. You can also take a reference of signal like there is a 1.65, okay, and in case of this proton that is a 5 to 6, and these proton will lie between 4 to 5, and based on the trans effect it will like more and less in case of both proton. So that statement is a false. Now the last statement is primary alcohol cannot be distinguished from the isomeric tertiary alcohol and their mass spectra. That is completely false, because we see that mass spectra can be easily identified 1 degree, 2 degree and 3 degree alcohol. So this again this is the like false statement. So which option is the correct answer? The option D. So again there is a similar type of questions where multiple concept was asked in a single question. That the first one related to the UV visible, then 13 CNMR, and then IR spectra, and then again 1H NMR. So that type of questions are in recent trend, and the multiple agencies are asking such type of questions, right? So let's try to solve these questions. Presence of homoannular conjugation diene with in a molecules can be detected by UV and visible spectroscopy. That is completely true, as in just previous questions we have discussed that okay, 1,3-butadiene and 1,4-pentadiene, they can be distinguished by using UV spectroscopy just because of the conjugation. So that is true. Okay, so that statement is a true. 13 CNMR spectrum compound confirm the nature of functional group in the compound. No, this statement is wrong. How it is wrong? We see that the carbonyl frequency, most of functional group like ester, like amide, like carboxylic and anhydride lies in the region of 170 to 180. So in this statement is wrong, because we cannot distinguish the functional group by the help of 13 CNMR, right? So that is false. Option like C, that isomeric ether and alcohol can be distinguished by IR spectra. Yes, they can be distinguished because the alcohol and the ether. Okay, now in the alcohol there is a prominent peak around, again as we discussed in the previous question, that is a broad and prominent peak obtained in case of alcohol, while in case of isomeric ether there is a CH3O peak. Okay, that will be around 1000 to 13,000 centimeter inverse. That will show in case of isomeric ether. So they can be distinguished by using IR spectra. That statement is true. In 1H NMR, the spin-spin coupling takes place between magnetic equivalent proton. No, magnetic non-equivalent. Okay, so that is false statement. So which code is matching with this? True, false, true, false, true, false, true, false. That is a D. Okay, so this kind of questions generally asking recently. So I have framed this kind of questions for inorganic, organic, inorganic and physical chemistry. So if you want these kind of questions in test series mode, then join the Telegram channel. Okay, you will get the Telegram channel link in the comment box, right? Thank you very much.